Welcome to another live demo from Automation Ladies. This is our second live demo of the year. If you didn't catch it, a couple of weeks ago, we did a live demo of the WinTech HMI development software, Easy Builder Pro. And for this one, we're super excited to have CJ Newhouse with us from Asyril. Hey, CJ. And we have Courtney with us today, which is perfect because out of the three of us, she is our robotics SME. And the story behind why we're doing this demo right now live is that you may or may not have seen on LinkedIn that the ladies visited Asyril HQ in Minnesota a few weeks ago. And CJ gave us this demo in person. It was just us. And we loved it so much that we immediately said, hey, everybody that we know should see this and we should do it on the show. And so we got it scheduled that day. And then I kind of forgot. And now we're here. So yay. No, we are super excited for you guys to see this. I think it was really eye-opening for us. Courtney and I, having a background in machine vision, we know how difficult it can be to set up machine vision systems, entire systems, including lighting, the right lens, the calibrations, everything. And this is not the entirety of sort of the product that Asyril offers necessarily, but this is and I'll let CJ explain this better, but a vision system tied into their flexible feeding system. And so he's going to show us how that works today. But that's kind of the premise of what we're doing. And a little bit of extra housekeeping / news for Automation Ladies. In case you missed it, we did announce earlier today that Automation Ladies has joined Industry Sage Media, which is a creator-led media company focusing on sort of real talk and behind the scenes expert-led content in the industrial automation industry. And we'll be joining some really fine shows from other folks, including the Unplugged IAoT podcast with Phil Saboa and Ed Fuentes, and a brand new show from former Phoenix Contact USA president Jack Nalick called Hey Jack. And there's another one called Future Trends with Ira Sharp Jr. And we're really excited because this helps us. We lost our audio editor, Laura, unfortunately, at the end of last year because our show got too busy and she got too busy with her job. And it was a part-time gig for her. So thank you so much, Laura, for everything that you did for us. We wouldn't have a show without you. But now we needed sort of a new partner or somebody to help us produce the show going forward. And Industry Sage turned out to be what we think is going to be a great partner for us going forward. They're going to produce the audio show and help us with the distribution and the production of the show. And that also frees us up to focus on doing our other things like this live. We're going to be doing more live demos this year and panel discussions, special episodes, like we'll have more cybersecurity special updates throughout the year. We've typically only done that once a year during Cybersecurity Awareness Month, which is, I think, November. So, yeah, I think you'll see, hopefully, more content, maybe a little bit more professional production as it relates to getting some more clips and shorts and more content out of the great conversations that we have at Automation Ladies. And then we'll be starting, I posted a little sort of intro preview episode of the season on the audio podcast today. So if you listen on Spotify or YouTube, Apple Podcast, those episodes should be uploaded. If not today, then tomorrow. It takes about 24 hours for some of those platforms to update. And then we should have a new episode for you every Thursday here, at least up until Automate. And so we're really excited. Thank you guys for tuning in, for being part of our community. We'd love your suggestions on what tech you want to see on live demos going forward. But yeah, I think that's kind of the gist. I already talked about my new job in my last live, so I'm not going to go into that too much. But Courtney, you have any words before we turn it over to CJ? Say hi, tell people what you're up to.
Hey, I need leads. That is all.
Okay. If anyone has robot integration leads or vision system integration leads for Courtney, she is open for work. I will also suggest, so Allie maybe I should be letting her make this announcement, but she's not here. Allie just took a job as automation manager at Kraken Engineering down here in Magnolia, Texas. And I haven't taken a job with WinTech USA earlier this year. There clearly is the opportunity for an employment relationship where we work with somebody and then also do the show and then also do OT Skatacon and some other stuff. So, Courtney, would you say you might be open to a fortuitous relationship like that as well if somebody sees that you may be a great part of their team?
I have made that note more than once. I'm a picky eater, so to speak, though. So full disclosure.
It has to be a really good mutually beneficial fit, right? So, but if you guys know anybody out there, or if you've ever thought, man, wish we could hire Courtney, then think about it, or DM her. So with that, I'm gonna throw up. Hey, we got some people here. Patrick, great to see you. I just met him. He's one of our speakers at OT Skatacon. He will be speaking on industrial networking. And we initially, Allie and I met him at Rockwell Automation Fair. And then I just had the pleasure of having breakfast with him in Alabama a couple of days ago. Ryan Treese. Ryan, thanks for joining us. Ryan's episode will be, I think, episode number 2 of season 6. So we had that conversation last year, but we were too backed up with episodes on season 5. So that'll be exciting. All right. So CJ, welcome. Thank you for listening to me drone on for almost 7 minutes. How are you doing today?
Introductions.
I'm doing good. Thank you guys for having me on. I'm excited to kind of show Asyril and I+ to everybody. I think, and I hope people who watch this can see the benefit of our products.
Yeah.
So I will get started here. So for those, I guess, who don't know about what flexible feeding is, it's taking bulk components and separating them for robotic pick and place applications. So kind of similar technology to bowl feeders, singulating parts for robots for assemblies, kitting applications, what have you. Except for flexible feeding is able to handle multiple different parts on the same system, whereas bowls are traditionally manufactured and designed for one specific part and require retooling if that design ever changes. What's really nice about flexible feeding, like I said, you can run, screws of multiple different lengths all on the same system, whereas a bowl might need to be retooled or have multiple bowls. So that's kind of where we fit in, is adding that flexibility to your automation line.
All right, I'm going to interrupt you real quick because you are an engineer and you'll get right into it. I want to ask, where you're in the back room there, which is your facility that we just visited. You've got a bunch of demos and stuff around. I don't know if you have the ability to turn the camera at all so people can kind of see what you got around there. No, it's stationary, right?
I could try. So this is our lab here. So I'm sitting at our AsiCube 240, and then we've got all of our different AsiCube sizes as well. So there's our smallest is AsiCube 50 and all the way up to our AsiCube 530. So we've got all of our AsiCube sizes available for use and testing here. Those sizes are measured, I guess, from corner to corner like a TV screen. So we can handle parts all the way as large as about the size of your fist, or 150 millimeters, all the way down to about 0.2 millimeters. So wide range of parts. We've got a bunch of different AsiCubes here. We've even got demos, one of which actually just shipped out.
Okay. I know you guys had,
fair.
Yeah, you had a bunch more demos. And then you guys have a bunch of really cool 3D printed stuff around too. Not necessarily part of this demo, but we were pleasantly surprised to find a bunch of 3D printed dragons and cows and cool stuff. So you guys totally please pay attention to the posts that we'll put out in, I don't know, over the next few weeks about our visit to Asyril. We had a ton of fun. I actually recorded a podcast, the Hired podcast with Travis Miller and the Miller Resource Group while we were there. And we put up a partition and everything. I was alone in the room, so to speak. But they probably had to edit that episode so bad because they just heard everybody laughing and having fun in the background. They were like, man, they really sounded like they were having fun back there. And I have to say, us ladies, we pretty much made a lot of new friends during this visit. I don't know. I mean, obviously, you guys were kind of forced to want to hang out with us. But what was your experience of that, CJ? What was it like having some weirdos come and like you have to show us around and show us your demos and stuff?
No, it was great. It's one of my favorite parts of this job as well is meeting new people and getting to show our products off. And the three of you guys were absolutely wonderful to host. And so I had a ton of fun. You know, the Mall of America was a ton of fun, despite me getting drenched on the log flume ride. Had to go buy new clothes. But it was a good time, and I had fun.
We'll never forget. So I think we'll have Taylor in the comments here as well, who arranged that visit with us, and she'll pop in, and if we need links for where to go or what people should be able to follow up or find other material, that sort of stuff, we'll hopefully see Taylor here in the comments. And then I just wanted to give a really big shout out to Matt Hunt, who is the general manager of Asyril USA, for believing that interacting with us in our community is worth something and bringing us out to your facility. And then as you guys see this, whether now or later watching the recording, if you think that you may have an application for this system or the AsiCube, these guys have all the sizes up there. They can test your parts. You can, send them a selection of your parts, and they'll be able to run a whole test for you and get you a test report and show you exactly what would work and what wouldn't. And they're the kinds of people that wouldn't sell you something that doesn't work. So, but they've got tons of 3D printers there, so they can like 3D print different plates for the cube. It's really a neat setup, and it's really great that you guys have that facility, and I hope that more people get a chance to go out and visit you. So with that, I'll let you now continue, CJ, with your demo. Thank you.
Sounds good. Okay, so I'm going to share my screen here. Let me see and make sure that this goes to the right one. Okay.
And Allie is joining us here in the comments as well. She thinks Matt Hunt is a really cool dude. Yeah, we agree.
Agreed.
And there's Taylor. Howdy, Taylor. She was just in Texas. You guys were both in Texas last week, right? So
yeah, Dallas and San Antonio.
Yeah. And I heard they spotted a WinTech HMI at one of the customers they were visiting. So
we did. Look good.
Allie says that this feels like they are a real family at that office. We don't like to necessarily say that. Hey, we are a family. Come work here. It's kind of creepy and can be sometimes misconstrued, but we really felt that kind of vibe, whether you want to say that out loud or not. That's kind of how we felt while we were there. So there we go.
It is.
Depends on how you feel at Thanksgiving about your own family.
Yeah. For us, it would be like chosen family, like the kind that you actually want, not the kind that you run away from.
Exactly. I mean, that was part of the reason why I took this job and have loved working here. Is it's very tight knit, so we all get along. Kind of have.
And you guys have how many Gen Z and like folks in the office now? You guys got quite a few, right?
Yeah, I think 3 or 4. I know Taylor and Connor are kind of towards that cutoff, but Luana and I are definitely we're both Gen Z. So. And that's one of those things that companies in our industry are struggling with right now is attracting and then also keeping their Gen Z workforce. So you guys are doing something.
Yeah, compare your DMs. They're all going to be like, "What made you stay?"
Yeah.
All right, let's go. Let's check this out.
Yeah, let's go. So this is iPlus Studio here that you guys are seeing. So Asyril offers, I guess, 3 different products. We have our AsiCube, which is the actual flexible feeder. It's able to vibrate parts in all 3 axes, so forwards, backwards, left, right, and flipping. We also offer our own vibratory hopper to feed the bulk parts into the AsiCube for separation. And then all of that is tied together by iPlus, which is our vision system and also control system. And so when you're using iPlus, it makes everything really smooth for integration. So you don't actually have to communicate with both the hopper and the AsiCube and the camera individually. You just communicate with the iPlus controller, and the iPlus controller is able to manage hopper vibrations and AsiCube vibrations independently. So when you're ready for a part coordinate, all you have to do is tell iPlus, hey, give me a part coordinate, and it'll manage all of those vibrations independently. And I'll kind of show you as we dive in a little bit further. But all of the software is within the controller. So all you do is connect into the IP address of the port that you're wanting to connect to, and it pulls up the software. It's not software as a service or anything. So once you buy the controller, you're good to go. There's no
perpetual license
gotchas or anything. Exactly. There's no gotchas there. And
a few years ago, that was the dirty word. You wanted like, no, I want a subscription. Now it's kind of like come back. It's like, oh gosh,
I know.
Do I have to subscribe
stay
to
away,
another
stay
thing?
away. Right.
Free revenue.
Yeah. So that's a nice part, and we've got some additional software options to be able to handle multi-part feeding as well.
Okay.
But really, to get you up and running, there's 3 different steps that you'll need to go through. You'll need to go through your camera configuration, and then you'll go through recipe creation, which we'll go through, and then your hand-eye calibration, which is mapping the I+ vision coordinate system to your robot's frame of reference, so that when you get part coordinates from I+, they're already in your robot's frame, so that you can drive right to that position. So if we just open up camera configuration here, I'll kind of just breeze through this. Everything within I+ is wizard guided. We really tried to make everything as simple as possible for those people who maybe aren't vision experts or automation experts in general. We have a lot of people who are first-time users. And so everything is step-by-step of, okay, turn the aperture to 5.6 because we have 2 different lensing options and both use a 5.6 aperture. Center your camera, so you've got a live view here. And so you want to center your ASIC or center your camera on the ASIC cube. Then you go through, set your orientation, adjust your focus, and then once you've gone through all the steps, you would click this Start Vision Calibration button. And once you're done, I+ will be able to map its pixels to millimeters. So once you've got this all set up, your camera's configured, you're ready to start actually doing recipe creation. So camera configured, you get a little check mark here. These 2 on first system startup will be grayed out. So you kind of have to go through step by step again, all in the name of ease of use, trying to make everything as easy as possible. Once we have our camera configured, the next step is to do recipe creation. And so this is actually where we get to kind of do the meat and potatoes and stuff. And so what I'll do is I'll take off the calibration grid here. So this is, you place this on the ASIC cube for your camera configuration. And then once you're done, you take your ASIC cube tray and you put it onto the ASIC cube. It takes 5 seconds to do. And then you can go ahead and create a new recipe. So these are the different additional software options that we have as well for multi-part feeding. So these are standard one-off purchases as well. These aren't subscription services. So we have multi-feeding, which allows you to have separated plates so that you can have different parts feeding on the same ASIC cube. So you could kind of have independent hoppers feeding into different sections for either kitting applications or assembly applications where you want to reduce your actual footprint. It allows for that flexibility without having to have separate systems. We've also got multi-model here, which allows you to train up to 6 different part orientations. So, for those kitting applications or those bagging applications, you might not care how the part gets placed wherever it's going. And so you can train up to 6 different orientations so that you can pick all of those orientations and speed up your cycle rate a little bit. For this one, what we'll do is just create a new single part recipe. And so I've got parts already on the ASIC cube here, separated 1/2 is good and 1/2 is bad. And so like camera configuration, everything is wizard kind of based, wizard guided. You've got some really helpful tool tips here to be able to kind of guide you through as well if you have any questions. So
it's pretty step by step. Courtney, I'm going to leave you to hosting for a little bit. It sounds like my dog needs help getting off the couch downstairs. So excuse me, I'll be right back.
Okay.
And I will note, as far as we're at for vision folks, watching, this ought to all look pretty familiar. But if you're a control freak like I am, and you're starting to wonder, like, where do I set my gain and all these other things that you want to be a control freak about, I pestered him when he did this demo, and he had to divert and show me where all the stuff is. But you can actually wrangle control as much as you want. As simple as they've made this, if you want to peel back layers and get into settings that he's not showing here, it's all there if you're the control freak like me. I just wanted to make that a side note.
Yeah, no, I'll go briefly over stuff, and I'll probably not go as in depth as some people might like, but
Yeah.
we've got a lot of different options as well, and tools to be able to kind of make it as advanced as you need, or as basic as you might want. So it's a kind of world's your oyster here. But even this first step is just image acquisition. So when we're setting up our recipe, we want to build up a database of images to be able to use for vision training. And so by default, I+ will take 30 images with the backlight. And if you've got a front light, it'll take 30 images with the front light as well. And those are the tools that you get to use, or those are the pictures that you get to use to train your vision model on. So during production, it's not going to take 60 images. It's only going to take, whatever images you actually use in the recipe. But we're given 60 to work with to try and, use at different steps. So like right here, you can kind of see how my exposure time varies from 3 milliseconds all the way up to 90 at a 3 millisecond interval. And so at any next step, I can use these different lighting settings. I've got backlight and front light as well. So a lot of tools for you to be able to use. But what this first step really is, step 2, which is really step 1, is to just determine what is a part and what is background. And so I+ has this really cool algorithm that we use to determine what is a part and what is plate automatically. And so it goes through all of the pixels and uses that algorithm to determine, okay, these pixels are really white and these ones are a lot darker, and so this must be a part. And so the goal of this step is to get all of the parts marked in green without getting any of the background noise included. And you can kind of see what I+ is seeing here as far as what is considered a part and what is considered a plate. Anything that is white is a part, and anything that is black in this image is background. And so I can adjust this however I see fit. Maybe I want to lower the exposure time a little bit to try and prevent any washing of the parts from this image. I might also want to apply a noise filter. So like if I've got dust or debris on my AsiCube, I can say, okay, anything that is 15 square millimeters or smaller is just background noise. It's just debris. It doesn't actually matter. I don't want it to be accounted for picking or potential collisions. And so once I've got all of the parts kind of, picked in green, I've set and separated the platform. So this half right here is all good parts, and then this half is all bad parts. I've even got some parts overlapping here. And what's really nice is I+ at this step will take a look at the average area of these parts on the plate and say, okay, majority of my parts fall within this range here. Anything outside of that is likely overlapping another part or is in the wrong orientation. So, if you picture these discs on their side, they're going to take up a lot less area. So that part would also be removed. You can bring these bounds in if you want. You can see my smallest part is 178.9 square millimeters, but my minimum here is 146. So maybe I want to bring that closer to 160. And I want to tighten up the upper bound, maybe closer to like 200. So you're able to change these if you want. Otherwise, I+ does a pretty good job of creating a min and max boundaries.
Do you find that people that know their parts, they probably kind of have a feel for some of these settings, or is this something that you have to really learn how the system works?
Honestly, this step, for the most part, will be pretty good at determining your minimum and maximum. But obviously, if you know kind of a general surface area that's going to be seen by the camera, you can tighten this up. We had a customer who was able to differentiate, I guess, part size. And there was only really 5 to 10 square millimeters of area difference, but they were able to see that difference. So you can tighten them up if you'd like. Otherwise, like I said, I+ does a pretty good job of creating those bounds themselves, or itself as well. So the next step is determining part orientation. So right here, you can't really tell, but these parts are upside down from these parts. And so what
you
I'll
can't really tell
do
that at
is
all.
maybe utilize a front light so that you guys can see. But these parts over here are all in the good orientation, and so is this one and this one. And then these ones are all upside down from that. And so what we'll do is I can use a front light image in this step, right? So I use the 30 millisecond backlight, but maybe I want to use a 45 millisecond front light to get a better definition between the parts. And so what this step is it's building an AI model to determine part orientation. And so what we're going to do is we're going to use our candidate detection step to build a database of candidates, and then we're going to go through and classify those, whether they're good or bad candidates. So if we go to our image database creation, what I like to do, and it makes my life a lot easier, is I will section an entire plate full of good parts. And this helps prevent me from making any human errors. I'm pretty prone to those. So
aren't we all?
I try to avoid setting myself up for failure if I can. So yeah, we'll take some images here. So you can see 27 out of 50 candidates detected. So like I said, using this candidate detection step, we're able to find these candidates on the plate and they store them in a database. So we need 50 total candidates to be able to start classifying these. So those first 27 are all in the good orientation. And then what I'll do is I'll flip them all over to the bad orientation. And I would include any other bad orientation that might get past that size filter as well. Just to be able to add those to the model to train them as bad. So once I've got those two images done, I've got my 50 candidates, I can begin classification here. And so I prefer to use this overview mode, which shows you the entire picture here. And so what I can do is I can just select good candidates and then go through and just start clicking them. And it tosses them into the good bin. So I'll go through and classify these ones. And then maybe I'll come over here to the next bad image, and I'll go through and classify these as bad. Once I've got 15 good and 15 bad, I+ says, okay, I've got enough candidates classified to be able to build a model, but I can always continue classification to train more parts. So if I want my model to be a little bit more robust, I can always add more parts. Then when I come over here to the results tab, you can see that my model is working well. I had moved all of the parts on the plate, so you can't verify that right now, but I promise it is working well. All of these are in the good orientation here, and all of these are in the bad orientation. And you can see that the lowest scoring good is scoring 89.4% good, and the highest scoring bad is 9.9% good. And so anything under this scoring threshold here would be considered bad, and anything above it would be considered a good part. So you can tighten this up if you'd like, or you can lower it. Or if you're not seeing enough distinction between these parts, you can always go back and add and classify more parts so that you can have a little bit more of a robust model. Okay. This looks good to me, so I'm going to continue moving along. I've got good part differentiation, and so the next step is just placing a pick point on the part, right? So we've determined that these are all good parts now. Now we want to define where our robot end of arm tool should go to pick these parts. So I'll jump back to a backlight image here. I find it provides a little bit better of part outline for the way that pick point positioning works. And so I+ will kind of map what it thinks are contours or features or faces that it's then going to match onto all of the parts that pass through this candidate selection step. And so, anything marked in blue, it's going to try and match onto another good part and then place a pick point there. So what I can do is I can kind of mask out some of these noise features here, like this. And then I can take this little circle from my toolbox and actually start to kind of line up this circle here so that when my pick point gets placed, it gets placed right in the middle of this circle. And you can see that it's locking onto the middle of this circle here. And I can lock on to this horizontal or vertical axis as well. Just some tools to be able to line up. But this target is where my robot will go. This
And does
part
this
height
work
here,
with any robot?
It does work with any robot. Yep.
Okay.
So I+ natively communicates over socket messaging, so TCP/IP. So most major robot brands that are used have the ability to communicate over socket messaging. Otherwise, if you prefer to use a PLC, we also have field bus modules that integrate with Ethernet IP, EtherCAT, or Profinet.
Okay.
So those are the 3 field bus modules that we offer and support. So a lot of different options for you to be able to use. And so we can see here that the blue outline is getting placed onto all of these parts, and you can see that it's getting placed with pretty high accuracy. This is a matching score, so how much of the outline is actually matching on to what I+ is deemed a feature. And so this is the lowest scoring part, and it's at 99.3% match, and you can see this pick point's getting placed right where I'd want it to. So this looks great to me. The next step is pick angle teaching. And so this works the exact same as pick point. It's just how do we want our end of arm tool to rotate to be able to pick these parts. What I can do is I can actually import that same mask from pick point teaching. So if I wanted to get rid of that noise, I don't have to come back and paint in. Let's say I had more of a difficult mask or a more complicated mask. I wouldn't need to go repaint that. I could also use a completely different mask if I wanted to. Let's say I didn't want to actually account for any of this blue here, this blue circle. And I just wanted to focus on these, I don't know, little out jutting things. Now all that will be matched will be this. And so
hang on, we have a question here from the audience. If you don't mind, I'll pop in. Levi is asking, no distance setting or different cameras?
So Asyril's standard only sells a 6.3 megapixel camera. We have 2 different working distances for each AsiCube size. So there's a long and a short that varies by size. And so there's a couple different working distance options. Right here, this pick point teaching, this part height here, and this production plate height are for parallax correction. So this is allowing you to account for parallax. And then in the actual camera configuration that we did earlier is where you would enter in your working distance of your camera. And so I think I skipped over that. That's my bad. But you would enter in your actual measured working distance there when you calibrate your camera.
Okay, thank you.
But yeah.
Thanks for asking, Levi. Anybody else has more questions, throw them in.
Yeah,
we
please.
prefer for this to be interactive. We were just talking about this earlier. CJ was like, so do I have to talk for 45 minutes? And I was like, and then Q&A at the end. And I was like, no. Let's try to do the Q&A as they come up. It's a lot more fun that way.
Yeah, much prefer that way. But what you can see here is what I'm able to do is actually provided a couple of different repeat angles. And so, we've got some symmetry within the part here. And so I don't necessarily maybe care which of these my part is rotating on. I just want to make sure that my x-axis is lined up with this feature. And so I can provide it with 6 different repeat angles. I could provide it with up to 20.
Okay.
So gives I+ a little bit more flexibility on how it wants to orient end of arm tool. And what's really nice is in this next step, when we're accounting for our end of arm tool, it actually will check all of those different angles to make sure that there's no collision, right? So if I have a part that's overlapping like right here, it'll actually check the other angles to see if it can pick at a different rotation. So what you do here is you take either your circles or squares and map out the space that you need your end of arm tool to have to come in and pick these parts. So if I had like a 2-finger gripper that was maybe 13 millimeters thick, and when it was open wide to pick, it was, maybe 24 millimeters wide when it's open to pick, I would center that along this part here. And now anything within this yellow exclusion zone would invalidate this part for picking. So if this part over to the right was closer, this part would no longer be pickable because there's an end of arm tool collision there.
Yeah.
And so I+ is able to manage that as well. The picking limits here is just to make sure that your end of arm tool has enough space away from the wall. So making sure that your end of arm tool doesn't collide with the wall. And then once you've got that, you're actually done with vision. And so any part marked in green is considered a pickable part. And this part coordinate would be provided back to your robot or your PLC. Anything in red is considered a bad part. And so you can see that it failed candidate selection here. And so once you've got your vision done, the last step is to tune the ASICube. And so I'm actually going to switch cameras. So you guys are no longer going to be able to see me. And you're actually going to see the ASICube, which is a lot cooler
Okay, let me move
than my face.
Should I move that to the main screen? Or do you still want the software on the main screen, the bigger one?
You can move it to the main screen. That might actually be better.
Let me see if I can change the layout here. Maybe I can't. Let me see here.
If not, that's okay too.
There we go. Well, I guess
There we go.
somehow, though, I lost the software part. Do we need to look at that one at the same time?
Maybe, yeah.
Yeah, okay.
Ideally.
Add to state. Okay, let me see if I can.
That might be okay, I guess, if they can just see the parts on the ASICube.
Yeah, we can still see it even though it's kind of small. And we have a quick question here. Was this pre-recorded to recap what I missed? Yeah, so the way that these lives work is that they are recorded while they're live, and then you can always watch the recap or recap. I don't know. You can watch it again. I guess I don't know if you can start it from the beginning right now, or as soon as it's done, then you can start it from the beginning and watch it again. You can also watch it on YouTube anytime. So thanks for joining. What we're seeing here, instead of CJ's face, is the actual ASICube, a camera pointing down. Well, that is the vision. That's the camera that it's using. Now we're seeing that camera feed up here in the left-hand corner while we're still looking at the configuration software on the main screen.
Yep. And so what this step is doing is actually training I+ on the ASICube movements. And so earlier I had talked about the benefits of I+ and how it was able to actually independently control the ASICube and the vibratory hopper feeding into it. And that's the real benefit of I+, is that all of those movements will be done independently. So when I+ takes a picture of the ASICube, what it does is it does all of the vision processing that we just taught it to do, but it's also calculating the center of mass of these parts, or I guess rather center of pixels of where the parts are. And it's also calculating how many parts are on the ASICube. And what it does with that information is it's able to move that center of mass to the middle of the ASICube before dispersing, so that we're not getting parts bunched up in the corner. And it's also able to adjust the hopper feed duration. So if we pick 10 parts off, the hopper is going to vibrate long enough to feed 10 more parts on, so that your ASICube's always optimally filled and it's always centered, so that you're maximizing your cycle rate. And so that's what we're doing here, is we're actually teaching I+, how do these parts behave. And so you've got control of the amplitude and frequency of these directions. So you've got forwards, backwards, left, right, or right, left, and a flip move here. And so what we're doing is we're telling I+, okay, when all my parts are lined up along this line here, it takes, X amount of seconds to go all the way over to the other end. And so if my goal is to maximize the performance of the system while decreasing this duration. So if I'm cheating here. I kind of already went through and tuned the ASICube before this, so I know the settings that work. But what you would do is you'd go through and you'd do a couple of different vibration tests to find the frequency and amplitude that move the parts the fastest. And what I found for these parts was 100% amplitude at 66 hertz, got the parts over in 1500 milliseconds. And so if I test that vibration, might get a little loud, sorry. So you can see that the parts move over to the other end. And then if I take those same settings and apply them to the opposite direction, we can see that the parts move over to the other end. And so my goal here is to get those parts to move from one end to the next in the fastest amount of time. So for this one, it ended up needing a little bit extra time. So 1750, you can see those parts move over there. And then if I do it in the other direction, copy those same settings. Yeah. And then, so once I've got all the directions tuned up, you can spend 15 minutes doing this, or you can spend 15 hours. I would err on the side of not 15 hours. Try and maybe spend 30 minutes doing it, get it 80% of the way there, because I+ will always automatically correct itself. So if it doesn't make it there in the first go around, it'll get there the second one. You'll still have some pickable parts, and it'll automatically always be recentering itself. So it's super, super handy. The last step we got to do is tune the flip move. And so we want these parts to separate well while flipping over to different orientations. And so again, I cheated here, but if I just click test vibration, you can see that the parts start to separate out and orient, right? So there's going to be some good parts here. There's some bad parts. There's parts overlapping. That's okay. We just want to be able to present a few parts to the robot to be able to pick. So once we've got the AsiCube tuned, which is what we just did, now we have to tell I+ how many parts need to be on this AsiCube. So if I tell it, maybe, I don't know, 30 parts. I try to get this fill percentage to 20%. What I've found is like a good general rule of thumb for part quantity, but this step 7 AsiCube configuration, your platform tuning and your hopper tuning, it's more of an art form than a science. So you'll probably have to do some trial and error to be able to figure that out. But what I'll do is I'll take all of these parts off of the AsiCube, and we're teaching it how long it takes to go from empty to full. And so that way then I+ knows, okay, if I need to feed on, however many parts, I know to adjust the vibration duration to feed that many parts in. So I do 50% amplitude at 500 milliseconds. I hit vibrate. Oh, wrong one. You can see that it feeds on some parts. That looks to be, I don't know, roughly about 30. You could go out and count them out if you want. But the last step is to build your vibration sequence. So you've got your platform tuning and your hopper tuning done. So now I+ knows, okay, how do the parts work? Now you're telling I+ what to do when you need more parts. So when I+ takes a picture, it stores all of those part coordinates in a queue. Mm-hmm. And once you pick all of those good parts, you need the AsiCube to vibrate again. And so that's what you want this sequence to run through. And so we typically see the smart feeding. So feed on however many parts I took off the AsiCube, which is right here. You've got your smart centering. So center the parts, make sure that they're not towards any of the walls. Flip the parts to separate them. And then I'll give it about a 900 millisecond stabilization time to let the parts settle before taking an image. Okay. And so, if I just hit run sequence here, see I+ flips. This time there wasn't any, but if I hit run sequence again, one good part here, right? So over the course of time, as you pick more parts and separate these, you'll just pick this part, ask for another part coordinate, and I+ will do the rest. So now you've got 6, so you go pick, rinse and repeat. The system will go all day long, all night long.
We got a comment here from Levi. That's actually genius for a part feed application. Yeah, that's why we wanted to show you guys this. I feel like there are so many things in our industry that, like, once you've seen them, you kind of forgot that you didn't know that they existed, but there's still tons of people that don't know that this exists. And so I'm super glad that you got a chance to see that. And thanks, Levi. Yeah,
it's super cool technology. There's nothing really like it in the US. We have a patent on the 3-axis vibration technology. So we're the only flexible feeder company that can manipulate parts like you're seeing here. And so we're really unique in that sense. And powered with I+, or paired with I+, you're really able to kind of make full use of all of that.
So without I+, how does the AsiCube work? You just have to integrate it with third-party stuff to get it to work?
Yep. Yeah. So you can still use the AsiCube with any other vision system. It's independent of that. You just have to tell it how to vibrate. So I would say vibrate forward for X duration, flip for X duration, or execute this pre-recorded sequence. You can still make use of these smart features without I+. The only downside is you have to be able to feed that information back, right? So you have to come up with the part counting with your camera and feed that back. You have to come up with the center of mass or gravity or pixel calculation on your own and provide the X and Y coordinates for that back. And then the AsiCube will do the necessary moves. So it really makes integrating this a lot easier, because really what you're doing is you're sending 4 commands to the I+ controller. Start production, prepare parts, get part coordinate, and stop production. and that's it. And I+ will do the rest. And so all you have to do is just program your robot to pick and place the coordinates that are sent back.
Really, really simplifies the integration.
Yeah, I mean, there's a lot of other steps that go into these automation projects. It's typically not just pick a part and place it somewhere.
Right.
Something else has to be done with that part.
Save your integration time for the other parts of it.
Exactly.
I've used kind of existing integrations, so to speak, or like say on UR, they have UR caps, like with vision systems and things that are already pre-integrated with vision and robots in the past, which I will always kind of tout if you don't know what you're doing, that's the direction I would go. But then if you do know what you're doing, setting up your own integration is, the control freak answer. But when it came to this and understanding, like, do I want to write the vision code for calculating the center of mass and then vibrating it this way or vibrating it that way? That's actually a lot of stuff that I barely know how to do. I'm actually impressed by. And I would say, don't do this yourself. Use this integration, because I can do robot and camera all day, but knowing how to vibrate something is, some black magic. That's like you were just saying, you could play with it for 15 minutes or 15 hours. So at some point you're going to cross the line into being lost in the weeds and spending tons of labor trying to figure out logically how to move stuff around. And this integration just does it for you. The camera and the vibrator, and the 3-axis vibration is stinking cool. I'll just say that.
Yeah, it makes everything super simple. And one of the benefits as well is an end customer, let's say an integrator purchases the system, integrates it, machine ships out, and the integrator support runs out. It gives power back to the end customer to be able to either make modifications to their own vision recipes without needing to be vision experts, or if they want to add another part SKU down the line, they're able to actually do it themselves without needing to kind of go in and mess around with a whole bunch of potentially difficult vision tools that they might not be familiar with. This is all fairly intuitive. So yeah, once we've got our vision recipe done, what we can do is finish and close, and we can come back to this home tab. And this is kind of going to be our home base, our launching point. So I told you we've got 3 steps: camera configuration, which we did; recipe creation, which we just finished; and then the last step is hand-eye calibration. So we want I+ to be able to return part coordinates in your robot's frame of reference, so that when you receive those coordinates, you just need to tell your robot to move there and go pick a part. And so if we open hand-eye calibration, again, everything is wizard guided. That's the whole goal, again, is to try and put everything into the user's hands. And so what we do is we take our recipe here called Automation Ladies.
All right.
Take one of these parts, and the premise is we're going to be putting one of these parts in each of the corners of the AsiCubes and taking a picture and localizing that with your robot. So we'll go to the first position. Again, guides you. Pick your part with your gripper. Move your robot to one corner of the ASI cube. Then what you'll do is you'll enter in your robot's coordinates. So because I don't have a robot here, I'm just a person, this is going to be designated as 0, 0. So if I type in 0, 0, that's my robot coordinate. I then release the part and move the robot out of the camera's field of view. And then I take a picture. And so now it's mapped this position in vision coordinates here to your robot's coordinates. So now it knows that this is 0, 0. Now what I'll do is I'll come pick this part up, move it over to the other corner here. So you do that with your robot. And then this one we'll call 0, 1. Release the part, take a picture, go to the third position here. So again, all of this would be done with your robot, not your hand. This one would then be 1, 1. And then take a picture. And then fourth position would be 1, 0. And now you've got your hand-eye calibration results. And I've got a calibration accuracy of 0.825 millimeters, and that's because I did it with my hands. This is kind of impressed with this, actually. I normally get in the range of 2 to 3 millimeters. So getting better at this. But I would suggest getting this down to about 0.2 millimeters or lower is your goal here. And you can validate that calibration too. So what you can do is you can move your part anywhere on the ASI cube and hit acquire a new image up at the top right here. And what this will do is it will provide you your robot coordinates and your RZ rotation to be able to jog to and then pick and validate and make sure that your calibration has been done correctly. If you're happy with it, you can validate and save. If you're unhappy with it, you can restart and do it again if you're seeing some deviation. For this, we'll just validate and save, and then we're done. I mean, we're good to start integrating and picking and placing. And so, I would then be able to start writing my robot code, and I'll maybe kind of show you a little bit of what that looks like here. So every recipe is generated with a unique recipe identification number. So this one is tied to the Automation Ladies recipe that we just created.
How many recipes can you have, CJ?
As many as you can store on your system. So it's got an internal storage of 15 gigabytes, but we also allow FTP servers. And so that's what we have right now is an FTP server. So we've got lots of recipes, 70 right now. I've personally never seen a customer hit the maximum storage size, because that'd be a lot of recipes on here. So
the reason I ask is because you mentioned this, I think, during the demo, but then also I recently saw a post from probably Vlad or somebody about recipes on PLCs, right? Whether you're actually hosting the recipes on the PLC or hosting them in a database and fetching them. So I think it kind of depends on your system, whether you have the storage to keep them all locally, or whether, as long as you can connect to an external database and then pull what you need, you kind of have that infinite flexibility.
Yeah, exactly. And I would recommend, if you can, keep them locally. It makes just modifying the recipes faster because you're not actually accessing them from a server. But if you've got a lot, then, like we will, and we do, we'll use remote storage for that.
Yeah, because you guys test so many different applications. Like you're probably running a lot more than a standard manufacturer would.
Yep, exactly. We typically see, maybe 6 or 7 on customers' cubes or I+ controllers, but, could be more than that depending on the application.
Yeah.
So if I go over here I copied our recipe ID. And so what I can do is I can tell I+, okay, I want to start production of this recipe ID. And this is the exact string that would get sent from your robot controller via socket messaging or your PLC via Ethernet IP or EtherCAT. This is what would get sent over to the iPlus controller. And once we start production of this recipe, if we come over to our dashboard, you can see that we're in the production state. And this is where we'll be able to actually get part coordinates. And so if I go back to iPlus TCP socket, and I just type in get_part, and you look at the webcam that I've got set up, you can see iPlus will kind of do a little weak flip there, provided a part coordinate. And then if there's another one in the queue, it'll provide it to me. Otherwise, it'll center and disperse parts and provide those coordinates back to me. So all I have to do is continuously call get part, and it'll continue to send me part coordinates until it runs out. And then it'll automatically vibrate again. Flip, provide me with part coordinates. There's also a command where I can see how many parts I have prepared. So if I do end parts prepared, I can now see, okay, iPlus has 4 more parts in the queue. So if I call get part 4 more times, the ASCII cube won't vibrate. See here, and I should probably just use up arrow. And then on this 5th get part call, right? So I did 1, 2, 3, 4. So now my queue is empty. So if I call get parameters and parts prepared, it says 0. There's no more parts prepared. I've picked all of them. The next get part call will trigger the ASCII cube and the hopper to vibrate if needed. We get a part coordinate. So you can kind of rinse and repeat, right? So 4 more parts, get part, get part, get part, get part. And if I want to kind of speed up my cycle, what I can do is I can pick this last part, and as my robot leaves the camera's field of view, I can send what's called prepare part. And what this will do is it'll trigger the ASCII cube to vibrate, but won't provide me part coordinates. So now when I call get parameters and parts prepared, I know, okay, there's 4 on there, but when I call get part and get this part coordinate back, it removes it from the queue automatically. So kind of provides you with a way to loop through your program X amount of times so that you can kind of optimize your robot movements if needed and know when the ASCII cube is going to vibrate. There's a couple more commands and parameters that you can use, but those are the 4 commands that you're going to need. Get part, prepare part, start production, and stop production. So
that's so simple.
That's the goal. So I'm gonna switch away from the webcam back to my face. Sorry, everybody. And then I will stop screen share, and that's
all right.
That's all I've got as far as iPlus.
Does anybody in the audience have any more questions? We're happy to answer them. Otherwise, this is perfect. We're right up on time.
It's like you rehearsed this.
Well, this is
I'm more of a wing it guy.
Here's what we ask for these demos for Automation Ladies is we don't want something specifically rehearsed for us. We want the thing that you do when people have an application or interest in your thing and they want to see your demo, right? Like most companies have some standard demos that they know how to do. If they know their product well, they can usually do them off the cuff without preparing too much. And that's exactly the kind of thing that we want to showcase on the show, because obviously it can't be specific to somebody's application because there's no customer in the audience specifically that we know of right now. And we don't have an application, but the idea is to let people that may or may not, know about this and or may have an application that they can see, hey, maybe I want to contact you guys now and see if you can run my parts and see what that looks like. But this is really just to kind of democratize the access to a standard product demo of something in our industry. So if you don't have a rep that's knocking on your door saying, see my thing, or, you maybe don't want to do that and have the rep looking at you directly in the face going, are you going to buy this at the end of the demo? Right? Like that's what this is for. Now you can watch this in your PJs on the weekend on YouTube and nobody's going to call you and say, do you have a PO for me? Although I certainly hope that, maybe that one day this will result in a PO for you guys. So if you watch this and then you decide that you want to use this, and you go ahead and contact them, tell them the automation lady sent you, because we'd love to know that this, is kind of valuable to either side one day. But that's really not, we're not expecting sales leads out of this, but general awareness, letting more people know that this exists. And then I think that there's probably more curious people just like us who, if we didn't have a job to do, I would love to just, walk a trade show floor all day, every day, and just look at cool demos if I got paid to do that and I didn't actually need to do anything else. But unfortunately, I think most of us don't get a chance to do that. So I would say take them where we can get them, and check out these cool demos on your own time whenever you got it, or join us live, because then that's even more fun. We get to interact. We can answer your questions. We do have, Levi has got another question. Best experience. Which feeds parts faster? 0.7 second cycle time, pick and place. Oh, as in what method? What pick method? I'm not sure if do you understand that question?
Maybe. I'll try and answer it. The most common robot type that we see for something of that speed is Scaras. We see deltas sometimes, but not that often. Scaras for that cycle time are pretty common. We do a lot of work with Epson and Fanuc Scaras. They're probably the most common ones that we see used here in the US. But obviously, there's tons of other robot brands out there. ABB, Staubli, those are also both really good robot brands. The cycle time of the AsiCube will really depend on the part and the orientation that you're picking in. If you're picking it in its most dominant orientation, then you're probably going to be able to achieve faster cycle times. If you're picking it in a very non-dominant orientation, then we're working against probability, and so your cycle rate might decrease a little bit. And say the average cycle time that a AsiCube can hit is probably close to 20 to 25. If you've got a really good part that is being picked in its most dominant orientation, you could probably see cycle times upwards of 30 to 45 parts per minute. But that's usually where we max out about. So you trade off some of that speed that a bowl feeder can provide you for the flexibility that we're able to provide. So,
as we know, there's always the trade-off. So good to know what it is up front, right? Another cool thing that we saw, like when you have long bolts or screws or that need to be picked up in a certain, you can also have like slotted plates, right? So where the parts kind of drop into the slot rather than just hanging out, like laying on the plate. And then there's also textured plates to keep parts from rolling. So if you have like a round part that would be moving around in between the time you take the picture and the time that you need to pick it. Yep, there we have a slotted plate. Then they have, they can
anti-roll.
Make custom anti-roll plates, to keep the parts from moving in between the time you picked or you got the pick point and then you actually get a chance to pick it. So very flexible system, can handle a lot of things, but ultimately these guys can test your parts and they can tell you exactly if it's going to work, how it's going to work, what your cycle times are going to be, that sort of stuff. So thank you so much, CJ. I really appreciate it. Taylor put a comment here in the big comment. Thank you, Taylor, with lots of resources where people can go if they want to learn more. And I also want to thank our sponsor, Automate, or A3, the Association for Advancing Automation, and the Automate Show. They are the sponsor of today's live demo and will be kind of a sponsor on the show up until Automate, which all of us ladies are going to be at. We are going to be there. So Asyril is in booth 818. I routinely forget the number of my booth. It's 3,600 something, I think. But honestly, who actually goes? Okay, this is a good. I'd love to hear from the audience if anyone just who writes down the booth numbers you want to visit versus just trying to remember the companies and then looking them up when you get to the show. Maybe some people are so detailed and planned out that they like map their numbers and stuff. I just try to remember what companies I'm trying to visit. So definitely make sure to stop by Asyril. What kind of demos will you guys have, CJ? Do you know what you guys will have in your booth there?
I do. Yeah, we'll have an actually quite a few robotic demos. So we're showcasing a couple of our new technologies. So we've got a concept project, Merlin. It's a bin picking solution. So we'll be presenting that with a robotic pick and place, picking out of a bin. So that's a product that I haven't shown you guys here today.
Cool.
So we'll have one of those demos. I'm currently working on a AsiCube 380 demo with a ABB 6-axis robot, picking and placing chapsticks. So come by and get a chapstick if you'd like.
All right. One of my favorite show giveaways because I always get dry eyes and chapped lips.
That was our thought process. Find something that would be actually useful to give away. Yeah. But we'll have a bunch of other robotic demos there. We'll have some other products that are new and upcoming that we're showcasing there. So stop by.
Sweet. So if you're going to Automate, see these guys. If you're not going to Automate, why? No, I know not everybody can make it, but it's definitely one of the shows of the year. One of the places where you get to see some of the coolest demos. So come see us there. We're going to be doing Automate Live. Us ladies are doing interviews in the Automate Live Theater. And we're also going to be in various different places throughout the show, including in the WinTech USA booth. And yeah, so we'd love to see you. So with that, we're going to sign off. And we have a nice little, if I can figure out how to put this on here, nice little video for Automate that we're going to play at the end. So thank you guys. See you later. We'll catch you. We have another live. I have a live coming up next week, live from the AHCD meeting in Atlanta. I'm going to do a little live recap like I did last year with Frank Hurt. We'll probably have him on again if he'll join me. And then we do plan to have these demos about every other week. So you will can expect that I'll probably schedule another live demo of something. I don't know exactly what yet, but we have a few things in the queue that we want to do. So hope to catch you in a couple of Thursdays here. And then I believe that week is also the Assembly Show South in Nashville. And Allie may be heading to that one. We're not quite sure which one of us ladies, if we're going to be able to make it or not. But go to, if you're in that, area of the country, in that neck of the woods, the Assembly Show South is quite a bit smaller than something like Automate, but it is in Nashville. There's some great companies there. Some of our friends from OT Skatacon, David Turner and Frank Lamb, are going to be there. Megan Zimba, our friend from Mavens of Manufacturing, and Ann Wyatt from Industry 4.0 are going to be there. So I highly encourage you, if you're around or close to Nashville, to go check that out, and you may see one of us. But still, the big bash of the year that we're looking forward to before our own con, OT Skatacon, is going to be Automate. So let me throw